our mathematics session. I kindly request Dhanurkar sir to continue with the mathematics session. Over to you, Dhanurkar sir.
Okay, thank you, madam. Say thank you to invite me for this lecture. And again, I hope all students they are knowing me. Is it visible the screen?
Yes, yes, sir. It is visible.
Okay, first of all, thank you. And again, thank you to VPKBIT Baramati for inviting me for this lecture. And again, believing on me after leaving this college also. Okay, thank you. Again, warm welcome all my dear student. Okay, we'll enjoy here this mathematics series for gate purpose. But again, my interest is that rather than this gate, I will try to create somewhat interest in mathematics. This will build up not only for gate, will be useful to your research purposes. I will move towards our this lecture without wasting more time. Is it visible? The screen?
Yes, sir.
Okay. Shall I continue? For this today's lecture, I will start with this simple part of linear algebra, and I will cover some examples on this linear algebra, and after that I will continue. In again linear algebra part, we have to discuss about matrices. Here, this matrices we discuss addition, multiplication, and its inverse. How to find out rank of matrix, to solve system of linear equation, and important part to find out eigenvalues and eigenvector for this matrix. I will introduce here first and then suppose I will take this matrix A. What is the order of this matrix? Order. How many rows? These are the rows. These are the rows. What is the order? 2 by 3. This is order. Now I have a matrix. A matrix. This is general fashion to write this matrix. This M. M are nothing but rows. And this N is nothing but column of matrix. This is called order of matrix. This is order of matrix. Now, in this order of matrix, we are knowing this order of matrix. Now, if I will take this matrix, suppose A1 is my matrix, 1, 2, 3, these are the elements. Then this matrix is called row matrix. Then I will take here A2 matrix as 1, 2, 3. This is called column matrix. Now here, how to find out addition of two matrices? I will write here addition of two matrices. Okay. How will you take this addition of two matrices? If I have suppose this A matrix of order m by n, and I have another matrix B of order p by n. Will give me answer, and I would like to take addition of two matrices. What conditions should be there? Everyone. Give me answer. Otherwise, this will be one-sided. Huh? How will take addition of these two matrices? Suppose I have this matrix A, 1, 2, 3, 4. I have another matrix B, 1, 2, 0. Shall I take addition of these two matrices? Yes or no? Shall I take addition of these two matrices?
No, sir.
No, we will not take. Therefore, what conditions should be there? Here, what is the order of this matrix? 2 by 2. What is the order of this matrix? 2 by 2. That means to find out addition of matrix, this order is matter. Means here, if we are to find out addition of these two matrices, then this order must be same. That means if P is equal to M, Q equal to N, then yes, we will get another matrix of order M by N, because we are keeping P and Q or M. To exist addition, order should be same. This is our first rule to find out addition. Now, if subtraction is there, again same thing. If we have to take multiplication, then what we have to do? Suppose I have A matrix of order M by N, and again B matrix of order P by Q. Now, which condition should be there? To exist A into B, we have to take product of these two matrices, and I will get C matrix. Now, what condition should be there? Yeah.
N equal to Q.
Yes, N equal to P. This condition. N equal to means number of columns of first matrix should be equal to number of rows of second matrix. And then we are getting finally order of this matrix is M by Q. Okay, this is just preliminary part of this matrices. Okay. Here you can just warm up. I will take here one example and just find it. A is equal to 1, 2, 3, 4. And I will take this B matrix. Shall we take here multiplication? 2 by 2. How many rows here? 2 rows and 1 column. Yes, we can take here 2 and this 2. This condition should hold. Columns of this first matrix and number of rows of second matrix. Yes, we can find. Come on, find out this A into B. A into B equal to 1, 2, 3, 4, 2, 3. How we are taking here multiplication? Just I am recalling this row multiplied to this whole column. And what will be the resultant matrix here? This matrix, order of this matrix is 2 by 2, and order of this matrix is 2 by 1. What will be resultant matrix? Resultant matrix. What is the order of this resultant matrix if we are taking multiplication? 1 matrix. Find out here this 1 into 2. Here I will take here for this first problem. I will take here 1 into 2 plus 1 into 2 plus 2 into 2. Second, 3 into 2 plus 4 into 2. What is it? 2 plus 6, 8. 8 plus 12, 20. Is it right? Again here in our this matrix, we can take something common is there, then we can take common. Remember, this is 8 and this is 20. Shall I take 4 common? Take here 4 is common. Remember. Now, if we are doing addition and multiplication, the next problem is to find out inverse. matrix. To find out inverse of matrix, this matrix should be a square matrix. A should be square matrix. What is meaning of square matrix? This matrix A is said to be square matrix. कब रहता है square matrix? I will take this matrix M by N. This is square matrix. If M equal this condition satisfied means A is a matrix of order 2 by 2, A is matrix 3 by 3, A is matrix 4 by 4, and so on. All these are the square matrices. And important here, one thing is identity matrix. Identity matrix is square matrix. I identity matrix 1 0 0 1. This is identity matrix of order 2 by 2. You can, and square matrix you can denote by A N also. This indicates this is square matrix because of rows and columns are same. This is identity matrix of order 2 3 I will take here n orders. N order identity. In general, IN indicate 1 0 and times 0 1 0 and so on. Now after this identity matrix, I will take square matrix A. Suppose I have this matrix A of this type. A, B, C, 0, B, E, 0, 0, F. This matrix is called, this is more of square matrix, no doubt. This matrix is called linear. These are the diagonal elements. These are the diagonal here. These are the diagonal elements of this matrix is square, then this is very clear to find out their diagonal elements. All these are the diagonal. Now these are the diagonal elements A, D, and F. Below these diagonal elements, all elements are G. This is called upper triangle. Sometime this may happen. I have one matrix. In this B matrix, I will write A 0 0, B C 0, D E F. Now again, all these are the diagonal elements, and above these diagonal elements, all these are the diagonal. Above these diagonal elements, all numbers are G. Then we are saying that this is lower triangular. In both cases, this is called triangular matrix. This is upper triangular or lower triangular. These are the triangular. Again, here I will highlight one more thing. Suppose I have this A matrix. This A matrix having element 1 0 0 0 2 0 0 0. अब मुझे बताओ, how many rows are non-zero? Non-zero. 2. 2 means here this is non-zero row. This is also non-zero, but this is a zero. Means here if all elements are zero in our row, then we are saying that this is a zero. And otherwise, at least one element here. All elements are zero, no doubt, but at least one here. Here also case, at least one is non-zero, then this is called non-zero. Help to find out rank of matrix. Idea. Now I will talk about inverse. Inverse is very easy. Now to talk inverse of this matrix. Now I will take here this. I have this A matrix. 1 0 0 2 0 0 0. Again, to talk inverse matrix, our matrix should be square. I am taking N is order of the matrix number. Now If I have this matrix, I will talk about its determinant. What is determinant of this? Who will give me determinant of this matrix? Again, remember one property of determinant. If at least one row is zero, if at least one row is zero, then determinant of this matrix here one zero or column is also here. If you are talking about column, at least one column is zero. If at least one column is zero, surely we are getting value of this. No need to calculate directly. We are getting now this matrix is zero. If determinant of this matrix is zero, again remember we are talking determinant for square matrix. Then this matrix is singular. Okay. A is singular. Suppose I have this identity matrix. And every time remember that what is determinant of identity matrix? Take any order 1, 0, 0, 0, 1, 0, 0, 0, 1. This is the identity matrix. 3. What is determinant of this matrix? I3.
1.
1.
1.
1. Determinant of identity matrix. Again, I will give hint one more technique to find out determinant of scalar matrix. It's a diagonal matrix. Suppose I have a matrix. A matrix is triangular. Triangular means upper triangular or lower triangular. Upper triangular or lower triangular. Is it clear what is meaning of upper triangular or lower triangular? Okay, I will take examples. Upper triangular or lower triangular or diagonal matrix or scalar matrix. If my matrix is either triangular or diagonal or scalar matrix, then determinant of this matrix is equal to multiplication of all diagonal elements. Remember, this helps to find out rank of matrix. My matrix is, I will take here example. Are you following or not? किसी को बोर नहीं हो रहा है ना? हेलो, हाँ हेलो, किसी को बोर हो रहा है? नहीं ना?
नहीं सर नहीं.
हाँ ठीक है, बोर होता है तो मुझे बताइए. 1, 2, 3, 4. I will take suppose 5 weeks. 0, 1, 2, 5, 0, 0, 9, 0, 5. Sorry. 0, 9. Suppose this is my math. Again, this such a type of problems may be there. Now this matrix is a triangular matrix. Okay, because these are the diagonal elements. This is 5 by 5 matrix, more or square matrix. This is 5 by 5 matrix, square matrix. Now all below this diagonal, all elements here, all elements are 0. These are the diagonal elements. All elements are 0. All elements are 0. Then this is a triangular matrix. And suppose problem is what is the determinant of this? Then what is determinant? Just multiplication of, if matrix is a triangular matrix, then just multiplication of all diagonal elements. Again, in an exam, they are asking type of problem. Find out orally answer. What is answer? 1 into second element into 3 into 1 into all these are the diagonal. Second diagonal, third diagonal, fourth. What is its multiplication? And because we are knowing property of triangular. Second, if I have this A is equal to 2, 3, 2, 0, 0. I am taking 3. 0, 1, 0, 0, 0. This matrix. Which type of this? Is it square matrix? Yes, this is square matrix because of the image. Now, triangular matrix. Triangular है, but upper triangular and lower triangular both condition. When this type of matrix here, this is diagonal. All these are the diagonal. This matrix is called diagonal matrix. Means here, all off diagonal elements are 0. All off diagonal elements are 0. This is a diagonal. Again, matrix is a diagonal. What is determinant? Just a multiplication of its diagonal elements. And your minus is the determinant. And I the scalar matrix. Suppose I have this B matrix and this is scalar matrix 0, 0, 3, 0, 0. This matrix is called scalar. Why this is scalar matrix? किसी को याद है? This is scalar matrix. Scalar matrix because is it diagonal matrix? Is it diagonal matrix? No. Is it diagonal matrix? Yes, diagonal. What is meaning of diagonal matrix? All off diagonal elements should be 0. Same condition satisfied. But in diagonal matrix, यहाँ पे 2 था, यहाँ पे 1 है, यहाँ पे 4 है, -4 है. But in scalar matrix, all diagonal elements should be same. Remember this. The diagonal matrix is scalar matrix. And both diagonal and scalar matrices are square matrices. And what is determinant? Determinant is called P is equal to 3 raised to power 4. I will write because 3 into 3 into 3. ठीक है 81 81. Now I will go to inverse. Again, before going towards inverse, again I will take to find out the rank of 1, 0, 0, 0, 0, 2, 0, 3. Okay, this is triangular matrix. All these are the diagonal. All these are the diagonal. This is a triangular matrix. Because below this diagonal elements, these are 0. What is determinant of this matrix? What is determinant? कौन बताएगा? Anybody? No. Audible to everyone? What is determinant of this matrix? Say. क्या है determinant? Here, at least one diagonal or matrix is a triangular matrix or diagonal matrix or scalar matrix. At least one diagonal element is 0. Determinant of this matrix. Now, if determinant is 0, then you will not find inverse of this. such a matrix. If determinant is 0, then this matrix is called singular matrix. Okay, what is singular matrix? Matrix A is a singular. Then determinant of this A, and if A is a non-singular, then what about determinant? Determinant is not a singular. And this determinant is equal to 0. Here, any element, I have one element. I have one element, my x element, and मुझे इसका इनवर्स निकालना है. Suppose मेरे पास 5 है. What is inverse of 5? I will take multiplicative. Multiplicative inverse यानी you have to take one such element A, दोनों का multiplication 1 आना चाहिए. One is called multiplicative identity. Now, what will be this A? तो क्या होना चाहिए? हाँ, 1 by 5. And this is equal to. Then we are saying that A, in this case, A is multiplicative inverse of 5. A is a multiplicative inverse of this 5, and we are knowing that multiplicative inverse of this a value of A is 1 by 5. This is the multiplicative inverse. That means here to find out multiplicative inverse, this number should be here. This number should be non-zero. Say, na? This number should be non-zero. That means if we are to find out inverse of this matrix A, then determinant should be non-zero. If we are taking determinant as 0, then we will not find its inverse. Therefore, to find out inverse, we should have a matrix of matrix is if my matrix, if matrix A is non-singular, then A inverse exists. If A inverse exists, what is A inverse? A into A inverse is equal to identity, or A inverse into A is equal to this condition. Then we are saying that this is inverse of matrix. Now there are several ways to find out inverse of matrix, but there are some simple problem. I will take here this one example. If I have this A is a non-singular, and this my A matrix is of order 2 by 2, A, B, C, D, and then what will be A inverse? Now remember this A inverse is 1 divided by AD minus BC into D minus B minus C. Find out inverse of 2 by 2 matrix. Easy formula. Again, you are knowing that this is the adjoint method because this part is a determinant of this matrix. You are knowing what is formula for adjoint? Inverse. Inverse is equal to 1 by mod A into J of A. Adjoint. This is your adjoint matrix and determinant of A divided. And we are knowing that if matrix is not similar, the determinant of this matrix is not equal. Determinant of this matrix is not equal. Non-singular. किसी को डाउट है इसमें? हाँ, तक का पार्ट जितना हुआ है किसी को डाउट है? अलग हुआ है? अब एक बात याद करके रखिए. In our matrices, suppose I have A and B two matrices. Suppose I will take A is matrix of order. A and B both are matrices of order n. A plus B is equal to B plus A. This happens. Means addition is commutative, but A into B did not equal to B. A into B means matrix multiplication is not commutative. Matrix multiplication is not commutative. Not fine. This example, this problem is there from your gate exam. Matrix P. Is it visible to everyone? Hello.
Visible is.
Okay. Now tell me what is the answer for this. Matrix P is the inverse of this matrix Q, and I is the identity matrix of that respective order with one of the following correct. Also correct one. A option, B option, C option, and D. Instead of A and B, we have this P and Q. P and what is Q? Q is nothing but, or P and Q both are inverse of this. P is inverse of this Q matrix. Like Q and Q inverse is equal to, and we are knowing that Q into Q inverse is equal to I. Also, this is equal to Q inverse into Q. Q into, what is Q inverse? It's P is equal to I, which is equal to P into Q. Which option is correct? Option C is correct. Because this part is P into Q is equal to I. Moreover, Q into P is also. Okay. Here, this is again property for determinant. If we have to find out determinant of this matrix, two columns are interchanged. Columns are interchanged. Remember this. In determinant, if we are finding determinant of this matrix, row are interchanged. Then value of determinant is unchanged. Value of this determinant is unchanged. But if we change instead of row, if you are changing by column, then value of determinant is, suppose whatever it may be, 2. If we are changing column, then that becomes a minus. Value is same, but change in your sign. कौन सा option है? यहाँ पे मैंने बताएंगे. We interchange row, value is unchanged, but interchanging columns, then value of determinant is same with change in sign. कौन सा option is correct है? Absolute value remains unchanged, but change in sign. Absolute value is same, means 2 remains 2. Suppose determinant of this P is anything, suppose 3. 3 रहेगा. But if we are interchanging this by column, then there may be minus sign. Your first option, both absolute values and sign will change. Actually, you can read all these options. Is it clear? First option is true because we are knowing that if we are interchanging column, then value of determinant is same but change in sign. Rank of matrix. इसको doubt है आपके? Hello. Rank of matrix. Now, find out rank of matrix. If suppose I have this matrix A, 1, 2, 0. I am taking this matrix. What is determinant of this matrix?
0.
Mute everyone.
0, sir. 0.
Determinant of this matrix is
0.
how this is 0. How will pass?
-6, sir.
Yes,
Minus
-6. Multiply by this minus this. We are finding this determinant. Determinant of this matrix A is equal to 1 into 0 minus 2 into 3, and which is equal to determinant of this matrix is -6. Determinant of this matrix is, if determinant of that matrix, here this matrix, this matrix is of order 2 by 2, and determinant is minus, or this is determinant is not equal to 0, then you can denote this rank of matrix is denoted by rank of this. Again, I will take here one more. I mean, this is just by finding our given problem is very simple. Easily we can find its determinant and get our answer. Suppose I will take here 0, 1, 2, 3, 0, 2. I have suppose this. What is determinant of this matrix? Again, one property to find determinant. If rows or columns are in multiple, or I will say that identical, then rows and columns are identical, then determinant of this matrix. See here, this is my 1 and this is 2. What about these two elements? Here, this is 0. Here is 0. Here is 1, but here is 2. Here is 2 and here is 4. Means this row and this row are same. Here, suppose I will say this is R1 and this is R3. But R3 is nothing but 2R1. Is it right? Rows are just multiplied by some constant, then we are saying that all these rows are identical. And if rows are identical, then clearly I will say that this determinant. Is it clear? This idea to this second rule to find out determinant of matrix. Determinant at least one row is 0, then value of determinant is 0. If rows or column, you can talk about column. If rows or column are identical, then this determinant is. Now, if determinant of this matrix is 0, then what I will do? I will take another matrix of order less than this. I will take suppose this order 2 by 2, because हमें पता है this B matrix of order 3 by 3 इसका determinant 0 आ जाएगा. छोटा matrix लेना पड़ेगा. Subset of this. Okay, this is called submatrix. What is the determinant of the submatrix? I will say suppose is the B1 matrix. 0, 1, 3, 0. What is determinant of this submatrix? B1.
-3.
And this is not equal to 0. Means parent matrix, this is our parent matrix whose determinant is 0. Then go towards a submatrix. I'm going towards submatrix of order less than this. पहले 3 था, अब 2 by 2. उसका determinant is. Therefore, we'll say that rank of this matrix. Okay? Rank of this matrix. This is just by inspection we tried. One more method is there, that is echelon form. By using that also we'll find out rank. Again, I will take here one more example. Tell me here what we find. Suppose I have this matrix A. I will take 3, 3, 3, 3, 3, 3. What is determinant of this? Again, not necessarily you should have square matrix. Any matrix. Find out rank and take any matrix. I will talk about first square matrix. Now this matrix is of order 3 by 4. Therefore, we will not talk about determinant of this matrix. Determinant of A not exist. If determinant is not exist, then what we have to take? We can take a submatrix. I will take submatrix. Suppose this is my submatrix. Now, what is determinant of this submatrix?
0.
You can take all possible submatrices of order 3 by 3. Suppose I will take this. What is determinant? The determinant be
0.
5. You can take here. Suppose this row, second row, fourth row, sorry, column. Then also you will get determinant. All elements are same. That's why we are getting determinant. Now we can go towards 2 by 2. Now I will take here this 2. What is determinant of this 2 by 2?
0.
Means you can take all possible 2 by 2. You can take this 2. You can means first A matrix का तो determinant नहीं ले सकते थे. Then I am going towards sub matrix of order 3 by 3. इसका भी 0 है. 2 by 2 उसका भी 0 है. अब क्या करना पड़ेगा हमें? We have to take a single element. Single element. Therefore, what is rank of this matrix? Rank of this matrix is clear. We are talking here two, and again remember that all elements are same. First row, second row, third row, all elements are same. If all elements are same for any matrix, then surely rank of this matrix. One here, rank of this matrix. This idea. After again, I am taking some problem. Okay, and then one method is there here. Why this method? What is this method? To find out rank of matrix. You should find out determinant of this matrix and check whether this is 0 or non-zero. If this is non-zero, then yes, we will get order of this matrix as the rank of matrix. If this is equal to 0, if determinant of this matrix is equal to 0, then what we have to do? There exists a one matrix, submatrix A, and then we have to find out determinant of this. Check whether this is 0 or non-zero. Till we will get non-zero determinant. और जो भी मैट्रिक्स नॉन जीरो होती है उसका नॉन जीरो डिटरमिनेंट आता है. Then another way can take this example and then tell me orally what is determinant. And मुझे अब इसका रैंक बताइए. Rank of this matrix. Which of the following is option? 5 minus 1. Options are given. A option is 2, B option is 5, C option is -1, D option is 1. What is rank of this matrix? हमने सीखा है कि if we have to talk about its rank, we have to talk about its determinant, whether this determinant is 0 or non-zero. If non-zero, then number of rows. Suppose this matrix is of order n, then rank of this matrix is n. What is determinant of this matrix? चलो जल्दी बताइए. What is determinant of this matrix?
-10.
Yes, -10. Again, we are interested whether this is what number. We are not interested whether this is 0 or non-zero. Is it 0 or non-zero? non-zero. You can find out determinant of this matrix is equal to -10. Non-zero. What is the rank of this matrix? Number of rows are sorry here options. What is rank of this matrix? Rank of this matrix is 4. Aya Dhanvi, is it clear? In our this previous example, we are checking here only order of this matrix. Here, this matrix is of order. This matrix A is of order 2 by 2, and I am finding its determinant. Yeah, determinant is not 0, then it's 2, order this 2. 2 को हमने रैंक कहा. This example, B is my 3 by 3 matrix, but इसका determinant 0 था. Therefore, I am not interested for determinant which is 0. Therefore, मैंने इसका sub matrix choose किया. B1 order 2 है. This is not equal to 0. Therefore, order of this B1 is 2. इस A matrix के लिए ये मेरे पास matrix है. इसका order 3 by 3 है. I have this matrix. The order is 3 by 3. I am finding its determinant, and we are knowing that determinant are all possible 3 by 3 matrices, sub matrices 0. Therefore, sorry, here this is not 3 by 3. This is not a square matrix. Therefore, I am taking 3 by 3. Any 3 by 3 sub matrix determinant is not equal to 0. मैंने बाद में इस पे sub matrices of order 2 by 2 check किया. Then also this is 0. Then I am going for sub matrices of order 1 by 1. तो कौन सा भी एक एलिमेंट ले लो, उसका ऑर्डर 1 है, determinant is not equal to 0. Therefore, this is 1. Clear? अब यहाँ पे directly if I am finding determinant of this matrix, because we are knowing that this matrix is quadrangular matrix, determinant orally we can find out. And if we are knowing determinant, yes, determinant is non-zero, then order of this matrix is rank of this. Is it clear? No.
Clear is.
Find out this rank of matrix by using echelon form. What is echelon? I have any matrix. To find out echelon form means we have to diagonal elements below this diagonal element into 0. I have this matrix A, A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A34, A34. Below this element, जो भी है, all these are again here. These are not directly diagonal elements, but roughly we say that these are the diagonal elements because this is not a square matrix. And we can find rank of any matrix. Rank of, you can find any matrix, any order. Here below this element. Means here by forcefully we have to convert these elements 0 by using row transform. We are converting below these diagonal element into 0 by using row transform. Then finally we are getting this structure as A11, A12, A13, A14, 0. A B element I will write here A dash 2. Change होगा A23 dash A24 dash 0 0. Now this element A33 dash कुछ तो change A34 dash. Since we are getting structure in this way, below these diagonal elements we are getting this element. We are getting structure. But remember that this is your first diagonal. This is my first diagonal, second diagonal, this is third diagonal. Then this form is called echelon form. The structure of this matrix is called echelon form. Again, I will give hint. Echelon form means this is my first diagonal element. This is my second diagonal. सेकंड डायगोनल एलिमेंट के आगे वाला एलिमेंट 0 ही होना है, मैंडेटरी. ओके, सेकंड डायगोनल एलिमेंट के पहले वाला एलिमेंट है 0 ही होना. देन दिस इज माय नेक्स्ट डायगोनल. ऑल दीस बोथ elements this type of structure is called echelon. And in echelon form, number of non-zero rows, this rank of matrix is equal to number of non. How many number of non-zero rows? This is called rank of matrix. Is it clear? Again, here this is my echelon form. Moreover, this is non-zero. This is non-zero. Non-zero diagonal element के पहले वाला element 0 ही होना. I will take here example. Get idea to find out rank of matrix. Here I am taking the same example which we have covered. Echelon form. Again, we have to convert below this element, this is diagonal element. These are not diagonal element. Roughly we are. I will use here this row transformation. R2 minus R1. That means I am converting this element into 0 and this element into 0. If I will use this operation. R3 minus R1. What will happen? This is first row 3. Below this element, I am performing this R2 minus R1 this operation. All these elements become 0. Now, if I am performing the second operation, this element becomes 0, this is 0. Okay. Now, how many number? Is it your echelon form? Echelon form में क्या है? echelon form में इसके नीचे वाले सब एलिमेंट 0 बन गए 0. अब ये मेरा डायगोनल एलिमेंट है, बट ये नॉन जीरो होना चाहिए. नॉन जीरो है तो उसके नीचे वाला एलिमेंट 0 होना चाहिए, ए वाला 0 होना चाहिए. कोई प्रॉब्लम नहीं, ये 0 है, ये भी होगा. ये 0 है, कोई प्रॉब्लम नहीं. 0 0 रो. Not very important. This is our final one. How many number of non-zero rows? Number of non-zero rows. एक non-zero row. Therefore, this is my only non. Therefore, rank of this matrix. Is it clear? And finally, is equal to 1, 2, 3, 2, 0, 1, minus 1. We have to find out rank of this matrix. Again, here, this problem is there in your exam. This matrix is 3 by 3 matrix, and this is very easy to find out directly its determinant and find out its rank of matrix. But if my problem, I will try to. Now this becomes difficult to find out rank by finding its determinant, because we will not find determinant. Number of ways are there to find out determinant. Number of sub matrices are there to find out. How to find out now? Suppose I will take now this. How to find out rank of this matrix? To find out rank of this matrix, we have to convert this element, this matrix, into echelon. Now, what is echelon form? Will give me idea. Write echelon form. Below this element, ये जो मेरा diagonal element है, इसके नीचे वाले सब. convert into 0. The operation we perform R2 minus 2R1 and R3 minus R1. Now get here 1, 2, 3, 1. First row I'm keeping it. Now multiply by 2 to first row and subtract. This is 0. Multiply by 2 to first row and subtract. Minus 4. 2 here minus 5. Here multiply by 2 and subtract. Minus 3. Then here this becomes 0. Minus 2. Is it clear? इसका doubt है इसमें? And now after this, we have to convert below this element. Firstly, convert below this element. And this element. We have to convert this element into 0. ये 0 करना है. We have this operation. 3 4R3 minus 3R. We will get here by this operation. 1, 2, 3, 1. 0 minus 4 minus 5 minus 3. This is 0. Now multiply by this row. This row multiply by 4 and this row by directly this book. Now we have to multiply this row by 4. Means this becomes minus 8. Minus minus plus 15. We are getting this as 7 plus. Now second row, if we are multiplying 5, 4. Is it clear? Is it your echelon form? Is it our echelon form? Okay, echelon form में क्या होता है? इसके नीचे के सब 0 करना है, इसके नीचे के सब 0 करना है. हो गए. और कंफर्म करने के लिए ये नॉन जीरो है तो इसके पहले वाला एलिमेंट 0 ही होना है. अब ए नॉन जीरो है तो इसके पहले वाले जितने भी एलिमेंट है वो सब 0. फिर 0. How many number of non-zero rows? Rank of this matrix is equal to number of non-zero rows. कितने हैं?
1, sir, 1.
For a non-zero rows. Non-zero rows means at least one element should be non-zero. Otherwise 0. 1 कैसे होगा? 3 है, 3 non-zero rows. No. Are you getting or not? Huh? One side. Hello. समझ रहा है कि नहीं? No. सूरज, सौरभ, सचिन, ऋतुजा, रोहित, हाँ? हेलो.
Yes, sir, yes.
आप सब लोग मुझे पहचानते हैं ना? हाँ? हाँ, स्नेहा तो म्हणते वो ओळखते म्हणून ना. रोहित, वो रोहित गांधी था ना? किधर गया? Now rank of this matrix is 3. Non-zero rows again I will clear. इसलिए तो मैंने पहले बताया था non-zero rows में just one. एक मेरा रो है suppose How many non-zero rows are there? How many non-zero rows are there? तो एक ऐसे अब तो देखो इस रो में एक भी एलिमेंट नॉन जीरो नहीं है ना? Therefore, this is called इस रो में सब एलिमेंट और बाकी के जो है ये सब नॉन जीरो क्योंकि इस एलिमेंट में ए एलिमेंट नॉन जीरो इसमें तो 2 है इसमें तो 3 है ठीक है नाउ आप फास्ट में चलेगा ना फास्ट में try to cover this system of linear system of linear two type of system रहते हैं x is equal to b and x is equal to 0 if x equal to b then this is called non-homogeneous here this system अब याद कैसे रखना है I will take here one example and then no need to remember this formula directly you can write this formula suppose मैं ऐसे एक तैयार कि मेरे पास एक I will take here we'll take I have suppose x plus y is equal to 3 and x minus y is equal to 1 ठीक है हाँ all these are the two distinct lines ये दोनों distinct line है इसका ग्राफ कैसा आएगा ये पहले लाइन का ग्राफ पहले लाइन का ग्राफ x is equal to 0 y is equal to y equal to 0 this is my line x plus y equal to 3 now x minus y equal to 1 x is equal to 0 what is y y is equal to minus 1 y is equal to 0 x is equal to 1 यहीं पे equation of this line is x minus y is 1 how many intersecting points are there सिंपल अलजेब्रा है 10th का एक ही है ना 1 पॉइंट कितने पॉइंट में इंटरसेक्ट करता है ये एक ही पॉइंट में चलो अब हम मैट्रिक्स फॉर्म में डाल देंगे एक गेट हाँ इसका मैट्रिक्स फॉर्म क्या होगा 1 1 1 minus 1 x y याद आया कोएफिशिएंट इसका कोएफिशिएंट 1 है ये 1 है तो पहला रो बन गया 1 1 यहाँ पे 1 है यहाँ पे -1 है 1 minus 1 y ओके आउट नहीं ना किसी को हाँ ठीक चलो अब मैं इसके बाद a this is our matrix system x is equal to b and this b is not equal to 0 therefore this is non-homogeneous क्या करता हूँ इस मैट्रिक्स के लिए ये दोनों का कॉम्बिनेशन ए मैट्रिक्स है as the what is A matrix? This is coefficient matrix 1 1 1 minus 1 this is 3 and 1 अब we have to convert this matrix echelon we will convert echelon form अब एचेलॉन फॉर्म में यानी कि ये जो एलिमेंट है मेरा पहला उसके नीचे वाला एलिमेंट वेट करना this transform I will use R2 minus R1. What we are getting 1 1 3 0. Here is minus 2 and here is it your echelon form? Yes. echelon form क्या कहता है इसके नीचे वाला जो एलिमेंट है उसको जीरो करो अब ये एलिमेंट होता है तो जीरो करना नहीं तो नहीं और दूसरी कंडीशन है ये नॉन जीरो है तो पहले वाला एलिमेंट जीरो now if this is echelon form what is the rank of this matrix number of non-zero rows how many number of non-zero rows
2.
therefore rank of this matrix AB is called augmented matrix rank of this matrix is 2
2.
how many number of unknowns are here x and y okay how many number of unknowns
2.
two unknowns number of what is the rank of this matrix 2 okay rank of this matrix is 2 I will drop here and I will write here this column for matrix B ये B matrix और ये बच्चे वाला कौन सा मैट्रिक्स है ये बच्चे वाला A मैट्रिक्स ऐसे my A matrix this is my A matrix this is my B matrix now मुझे बताओ what is the rank of matrix A what is rank of matrix this is my A matrix
2.
A का भी 2 है B का भी 2 है and number of unknowns equal to 2 यानी कि मैं ऐसे लिखता हूँ rank of matrix A is equal to rank of augmented matrix A 2 2 is number of then in this case how many solutions are there in our system ये तो हमें 10वीं में पता how many solutions only one solution means if we are getting this condition rank of matrix A is equal to rank of augmented matrix which is equal to number of unknowns then we are getting unique okay means I will write here this observation rank of matrix A is equal to rank of augmented matrix AB which is equal to number of unknowns then this system having we will take another example this is the observation I will take here second example in second example I will write here in this way I will take here x plus y is equal to 3 and 2x plus 2y equal to 6 come on your points x is equal to here I am getting 3 here I am getting 3 and this is my equation line this is my line x plus y is equal to 3 this is like sorry second line का equation क्या होगा
Parallel to that, sir.
this is parallel x is equal to 0 we will get here somewhere 5 here is somewhere 5 then I will give idea here these are nothing but their direction ratio these are the direction ratio if direction ratios are proportional 1 1 है direction ratio पहले लाइन के दूसरे लाइन के 2 2 ले लो या can you write down k direction ratios are proportional then we are knowing that these are the parallel lines these are the parallel we are knowing therefore these are the parallel lines if lines are parallel then what will happen if lines are parallel then is there any intersecting point is there any intersecting point of this no therefore no solution this condition Now I will check how we will talk about the rank of matrix. Now I will write this into matrix form. Matrix form में कैसा होगा ये 1 1 2 x y 10. Is it right? This is our ax. I will write here augmented matrix AB for augmented. Augmented matrix. This is 1 1 2. A matrix and this is 10. That means 10 here. This B matrix. And only insert B matrix. Convert into echelon form. echelon form में convert करने के लिए A मुझे 0 करना है. I will write R2 minus R1. We are getting 1 1 0 0 0 0 4. Is it clear? And now this is my echelon form. What is rank of this matrix?
2.
What is the rank of this matrix? This is my A matrix. What is the
One.
rank of A matrix?
One.
1.
1.
Rank of this matrix. That means the rank of matrix A is not equal to rank of augmented matrix. In this case, we are getting how many solutions? Only condition I will repeat here. Observation. If rank of matrix A is equal to rank of augmented matrix AB, which is equal to number of unknowns n, I will write. N is number of unknowns. Then our system having unique solution. अब second case क्या हो? Rank of matrix A is not equal to rank of this augmented matrix. Then system having no solution. Clear? Here, no need to remember because we are knowing two parallel lines and this is in our 1000. We are knowing all. I will take here one more example. I will take here x plus y is equal to 3. This is only one line. How many solutions are there? X plus y is equal to 3. This is only one line. How many solutions are there? Any point on this line. X is equal to 1, y equal to 2. This is solution. Y is equal to 1, x equal to 2. This is solution. Y is equal to minus 4. Again, corresponding to that, if we are taking x is equal to 7, we will get solution. How many solutions? Infinite solution. Because solution means such a x and y satisfying this equation. Infinite solutions. Now, what is matrix form? 1, 1, x, y, and this. This is our matrix form. We can represent this equation into matrix form. This is linear equation. What is the augmented matrix of this? Or I will write this as x is equal to b matrix. Augmented matrix. What is augmented matrix? 1, 1, 3. This is augmented matrix. This is my B matrix. I am taking this. I'm talking about all non. What is rank? And this itself is a echelon form. What is the rank of this augmented matrix?
1.
1. Rank of this augmented matrix AB is 1. What is rank of matrix A?
1.
Rank of matrix A is 1. N is equal to number of unknowns. कितने हैं यहाँ पे?
2.
2 है. That means we are getting this case as rank of matrix A is equal to rank of augmented matrix A, which is equal to n. But यहाँ सर जो है ये सेम है, but this is less than equal to n. ठीक है? n is number of unknowns. This is less than equal to n. This is 1 है. And this is 2. And in this case we are getting how many solutions? Infinite. Here I will write Again here, if you in your exam, if you are in confusion to find out what is rank and how to check whether our system is having unique solution or infinite solution or no solution, then you can go through such a simple example. I have to just formulate directly one formula, use it your result. Remember, here I will write note. N, what is N? N is a number of, what is first? If rank of matrix A is equal to rank of augmented matrix AB, which is equal to N. How many solutions are there? Unique solution. I will write. If rank of matrix A is equal to rank of augmented matrix AB, and this is less than N, how many solutions? Infinite solutions. Okay. Here, third case. Third case क्या है? If rank of matrix A is not equal to rank of augmented matrix, then in this case our system having, is it clear? What doubt है?
No, sir, no doubt.
Oh, very good. Means here you are knowing all this thing. Okay, here in both cases we are getting solution. Both cases we are getting solution. एक में infinite है, एक में unique है. कोई problem नहीं है, लेकिन solution तो मिल रहा है. We are getting solution. Having solution, such a type of system is called consistent. These two systems are called consistent. What is the meaning of consistent? If our system of equation possesses at least one solution, एक भी solution मिलता है तो उसे consistent बोलते हैं. Otherwise, this is not a consistent. Otherwise, inconsistent. This case is inconsistent. Having no solution. Having no solution means this system of linear equation. I will write here. This system of linear equation X is equal to B. This is non-homogeneous. This non-homogeneous system either is consistent or inconsistent. If consistent, having this case, rank of matrix A is equal to rank of augmented matrix AB, which is equal to N. This is unique solution. Second case, rank of matrix A is equal to rank of augmented matrix AB, which is less than N. यहाँ पे एक ही केस है, रैंक ऑफ मैट्रिक्स ए इज नॉट इक्वल टू रैंक ऑफ ऑगमेंटेड सिस्टम हैविंग नो सॉल्यूशन. ओके, ठीक है. नाउ वी विल टेक दिस प्रॉब्लम. नाउ रीड दिस एग्जांपल. एवरीवन रीड दिस एग्जांपल. ट्राई टू सॉल्व. This example was there from your last GATE exam. Consider system of this linear equation. System consistent. System is consistent if A and B is satisfied. Which property? Now, if we are to talk about consistency, then we have to talk about its rank. I will go through this problem is for 2 marks. Huh? In your exam, 2 marks. Now, easily we will solve this. Right down here, this exam directly into matrix form. कौन सा matrix आएगा? 1, 2, -3. Shall I write directly this augmented matrix AB?
Yes.
2, 3, 3, 5, 9 -6. और A है A, B, C. This is your augmented. चलो कन्वर्ट करो एप्सिलॉन फॉर्म में. हाँ हरे. This transform we have to convert this element into 0, this element into 0. Convert करना है. Therefore I will use R2 minus 2R1 and R3 minus 5R1. 1, 2 minus 3, A. This is 0. Multiply by 2 and then subtract here. Minus 1. Multiply by 2 and subtract here. Here is 9. This is B minus 2A. Then this is 0. Multiply by 5 and subtract here. Minus 1. Multiply by 5 and subtract here. This is 15. 21. 21 होगा ना? चेक करो. Sorry, minus 15 plus 9 ही होगा. C minus 5A. This is my B. I'll do not. Then we have to convert below this element into 0. इसको 0 करना है. Therefore, I will use R3 minus R2. 1, 2 minus 3A. 0 minus 1, 9B minus 2A. 0, 0. अब A भी बन गया है 0. अब we have to take multiplication on this. ये दोनों का multiplication करना है. Right here. 5, sorry. C minus 5A. अब we have to take minus B plus 2A. क्या होगा ये? C minus 3A minus B. C minus 3A minus B. हाँ, we need consistency. कंसिस्टेंसी के लिए कंडीशन क्या है? ये तो कंडीशन है ही कंसिस्टेंसी की. तो सेम आना ही है. रैंक ऑफ मैट्रिक्स ए इज इक्वल टू रैंक ऑफ ऑगमेंटेड. अब लेस देन है या इक्वल टू है, देन यू विल गेट अ यूनिक सॉल्यूशन और इनफिनिट. ये मेरा टोटल ए है. दिस इज माय ए एंड दिस इज माय बी. अब रैंक सेम करने के लिए व्हाई व्हाट वी शुड हैव, ए सपोज नॉन जीरो होता तो क्या होगा? Suppose this is not equal to 0, then what will happen? What will be rank of this matrix A, B? P होगी. If suppose I will take non-zero, तो उसके लिए मुझे क्या बनाना पड़ेगा इसको? This is equal to 0. And if I will take C minus 3A minus B equal to 0, then we will get this. And then it becomes a consistent. Then what is your answer? C minus 5. Yeah, answer is there. We have to take plus inside. ये इसको plus कर. This is equal to 0. This is equal to 0. Right here 3A plus B minus C equal to 0. कहाँ पे है? 3A plus B minus C. 3A plus B. इसका डाउट है? Hello.
No, sir.
You'll get here. Just I am here again. ये problem को having infinite solution. This problem is here again from your GATE exam. चलो हरे. I will write here AB. I will solve this first. 1, 1, 1, 1. A minus A 3, 5. 5 minus 3 A 6. Convert into echelon form. 1, 1, 1, 1. We have to multiply by A and subtract. Multiply by A and subtract minus 2A. Multiply by A and subtract 3 minus A. केयरफुली करो कैलकुलेशन. 5 minus 0 multiply by 5 and subtract. Minus 8 multiply by 5 and subtract. 5 minus 8. One, 0 minus 2 8 minus 8. Please mute yourself. Multiply.
आम्ही 40 रुपयाच्याच खाल्लंय.
Mute yourself.
पाण्याची बाटली दिसतादारी आणि ते सगळे बरोबर हिशोब जाते.
नाही रे अभिरा 40 रुपयाचं घेतलं आम्ही 10 रुपये बाटली फक्त 50 रुपये बाकीचे 50 रुपये तर द्या.
अरे फायनान्शियल सगळं आम्हाला कळायला लागलं तुमचं.
50 नसते होती दर 5 रुपये.
ये
5 घे
this
दर
is
5 तुला 20.
we have to multiply this third row. I will write here.
800 नोट.
हिला मागितलं.
म्हाताऱ्या कोण नीट
पहिला
द्यायचं.
हिला दिले आणि आता 20 दिले हिला 30 माग.
छोटूचं बरोबर आहे.
I will
छोटू
multiply by here. A
छोटूचे 30 रुपये राहिले होते त्यात 10 रुपयाची बाटली 20 रुपये राहिले.
minus
5 रुपये दिले.
नाही 10 रुपये पण
4R.
विचार केलोय.
हे छोटून तुझ्या 10
परवडला नाही गोविंद ने हिने फ्रॉड केलाय.
Multiply this row.
पण 5
This row by A and then subtract from this row.
दिले ना
A into 5 minus A
तुला 5 रुपये कमी.
minus 6
40
plus
रुपये
2.
सँडविचचे.
अरे कोण गेलं बाहेर ते क्विट करा त्याला.
200 होते.
हा ठीक.
पाण्याची बॉटली होती आपल्याकडे. 5 रुपये दे भाऊ. घरी गेल्यावर दे.
अदिती अरे अदिती कुठे आहे तू? हा ठीक. Then we have to multiply here. This is 5A minus 2A. That means this is 7A minus A square minus 6. 7A minus A square minus 6. And for this we have to multiply this by A and subtract from. Okay, गड़बड़ है क्या? So this should be 0. 0. Hello, is there any mistake in our calculation? Okay, I will solve suppose this. This is A square minus 7A plus 6 equal to 0. 6 and 1. Are you solving this? No. Hello? What is your answer? What is your answer? Okay, solve this. Okay, I will go ahead. Now tell me answer for this. Orally we can find out. Okay, orthogonal matrix. I would like to give a definition of matrix. Orthogonal matrix. This matrix, Moreau square matrix, is orthogonal if A into A transpose equal to A. if A into A transpose equal to identity. Now remember, matrix A is orthogonal, A transpose equal to A inverse. Matrix A is orthogonal, then A transpose equal to A inverse. Now which one is the option here? Now again here, again this problem was there in 97, I think. 1997 batch. Purana problem. I will again discuss about quadratic. What is quadratic form of our matrix? Here,
So option B है.
यहाँ पे ना, हाँ option B है, okay. But I will discuss here form for 3 by 3. And this is always वो symmetric होता है. यहाँ पे symmetric होता है. Always this is symmetric. This is A11 x1 square plus A22 right here B11 y1 square plus C11 z1 square plus 2 A1 B1 xy plus r xy right here. X and right here 2 A2 B2 y z plus 2 A3 B3. I will write this quadratic form. Here A11 square जहाँ पे term है वो all these are the diagonal y square and z square. A11 C1. Here this is xy. Xy means I will write here A1 B1. This is symmetric A1 B1. Here A2 B2 y z K. A2 B2 A2 B2 Z3 A3 B3 E3. Is it clear? This is called quadratic form of this matrix or quadratic form. This is for 3 by 3 matrix and this is for 2 by 2 matrix. 2 by 2 के लिए क्या होगा? Only x square y square all this. First term, second term, and a term. Not 2 by 2. Therefore again here A11 यहाँ पे x1 x22 means this square term x square and you will get here quadratic form. Just a definition. इसके बाद कभी नहीं पूछा ये but this was there. Now tell me here how. ठीक है. I will go for eigenvalues of eigenvector. Main part. And eigenvalue eigenvector. This is my x is equal to I have a square matrix A. Square matrix and of order n. If this is a square matrix of order n, then eigenvalues. You can find eigenvalues. A minus lambda I determinant is equal to 0. You will get eigenvalue. This is called characteristic equation. This is characteristic equation and roots of this characteristic equation. And here ax minus lambda x is equal to lambda x, and this x is called eigenvector Keep in mind this x should not be 0. It should not equal to 0. This lambda is called eigenvalue. Then this lambda is called eigenvalue. Again, here I will use some properties of this eigenvalue. This is important. All properties. Properties of eigenvalue. Again, remember here, if my matrix A is of order n, then this having n eigenvalues. Okay. If matrix A is of order n, then this matrix having n eigenvalues. Now I will write here first property. If lambda is first property, product of all eigenvalues is determinant of this matrix. Always this happens. Then sum of all eigenvalues is equal to trace of matrix. What is trace? Trace means addition of all diagonal elements. All diagonal elements. Sum of eigenvalues is a trace of matrix, and product of eigenvalues is a determinant. These are the very important properties. Using these properties, you can solve problems. If I will take, if lambda is eigenvalue of A, then I will write here. Then lambda square is eigenvalue of A square. Then lambda square is eigenvalue of A square. Then here I will write here lambda raised to power k is eigenvalue of A raised to power k matrix. Again here, if lambda is eigenvalue for matrix A, then lambda minus, I will take suppose k into I, minus k only. Minus k is eigenvalue of A minus ki. This is identity matrix. You can take plus also, huh? Doesn't matter. Plus, then I will write. If matrix is non-singular, you can find here. If lambda is eigenvalue of A, then lambda inverse is eigenvalue of A inverse. Lambda inverse is eigenvalue for A inverse. I think all these are the properties, but we'll use all these properties, and if additionally if we are recalling, then again I will add all the properties. But try to remember this property. This one, this is A inverse, and this product of all eigenvalues is the determinant of matrix, and sum of eigenvalues is trace. Consider this matrix the number of distinct eigenvalues. Again, I will write here. If matrix is a triangular matrix or upper triangular, if A is triangular or diagonal, then diagonal elements are eigenvalues. Then diagonal elements are eigenvalues. Now this is a triangular matrix. Triangular matrix. Which are the diagonal elements? Therefore, eigenvalues are. Which are the eigenvalues? 1, 1, 1. 1, this is 1, this is 1. Are you here, everyone? कितने लोग हैं? 7 लोग हैं. Is it audible? Are you listening or not here? Hello. Okay. ठीक है, आप तो है. Okay, thank you. Okay, I will see you. Now this is the important part, point of your exam. These are the eigenvalues. But how many distinct eigenvalues? कितने distinct eigenvalues? 1, 1, 1 repeated है ना? और हमें पता है कि if this matrix triangular, then determinant is nothing but product of all the eigenvalues, and we are getting these are the eigenvalues. If we are taking product of all eigenvalues, determinant. Yes. How many eigenvalues? Only one distinct eigenvalue, and remaining are repeated. हाँ, ये इसके बारे में बताओ मुझे. Again, space is given, means we have to write answer here in 2 decimal form. 2 decimal form. What is given? If I have this matrix A, then we have to find out determinant of A inverse. Here we'll take a use of this eigenvalues. What are the eigenvalues of this matrix? 1, 4, 1. These are the eigenvalues of A. What are the eigenvalues of A inverse? A inverse के eigenvalue क्या होंगे? 1 by 1, 1 by 4, and 1 by 1. That means here I will write here this as 1, 1 by 4, and 1. These are the eigenvalues for this matrix A inverse. A inverse के लिए eigenvalues. We have to find out determinant. What is meaning of determinant? Determinant means these are the eigenvalues. Determinant of A inverse is nothing but product of all eigenvalues. What is product? Product is 1 by 4. 1 by 4 is 0.25. And we need answer up to 2 decimal. My request is that everyone go through this eigenvalues and eigenvector. Surely problem is there. Obtain eigenvalues of this matrix. This problem was there for 5 marks. Again, this is for 5 marks because this is, I think, in before 2000, means 1993 का और 97 का. ठीक है, हम इसके फाइंड तो करेंगे. Find eigenvalues. Suppose options are given. How will find A minus lambda I determinant equal to 0? तो ये क्या आएगा? A minus lambda I. Lambda I means here. That's minus lambda I. Here minus lambda into I. 1, 0, 0, 0, 0, 1. तो diagonal element में ही सिर्फ हमें change करना है. यानी कि 8 minus lambda minus 4, 2, 2 minus lambda. This is equal to determinant solve करो. 8 minus lambda into 2 minus lambda minus minus plus 8. This is equal to 16 minus 8 lambda minus 2 lambda plus lambda square plus 8. This is equal to lambda square minus 10 lambda plus 24 is equal to. Now we have to find out factors. कितने होंगे factors? Lambda is equal to 10. Which are the factors?
minus 12 plus 2.
Minus 12 plus 2. Means this is 12 and lambda is equal to minus 2. Lambda is equal to minus 2. These are the eigenvalues. Now you can check all these eigenvalues are correct or not. And this is your answer. Your answer is lambda is equal to 12 and minus 2. You can check your answer. What is determinant of this matrix? Determinant of this matrix equal to 16 plus 8 is equal to now what is product of these two? Minus 24 minus here we are getting product as minus. Oh, something is wrong here. Here is plus sign. Then these are not a roots for it. This is 8 minus 2, 16 minus 8 minus 2 plus lambda square minus 10 plus 24. These are not a roots. Determinant is minus 24. Determinant should be minus 20. Product of, again here remember, product of eigenvalue is determinant. Lambda 1 into lambda 2 is equal to determinant of this matrix. And lambda 1 plus lambda 2 is equal to trace of matrix. Lambda 1 plus lambda 2 10 आ रहा है, ये trace है. Determinant नहीं तो गड़बड़ है. Okay, this was in our theory, but try to remember how to find out. And if options are there, then you can check option by using these two results. Product is determined and sum is a trace of.
सर अजून एक फॅक्टर येते किती सर?
अजून नाही.
मायनस 6 आणि 4.
Minus
6 आणि 4.
6 and 4. He is correct. 6 and 4. Minus 6 minus 4. Yes, 6 and 4. 6 and 4, 10. Yes. Yes, yes. This is your.
सर -4 येणार. 6 आणि मायनस.
नाही मायनस नाही. दोन्ही मायनस येतील ना. Lambda square minus 6 lambda minus 4 lambda plus 24.
-9.
Now yes, this is correct. याचे रूट्स काय आहे? -10. For -10 ला आपण -6 -4 असं लिहितो. -10 is equal to -6 plus of -4 असे. तर त्यांचं मल्टिप्लिकेशन 24. आणि असे 6 and 4. Now this is correct. Now you can check whether this is correct or not. What is their multiplication? Multiplication is 24. Yes, this is 24, and that means this is determinant. What is addition? Addition is 10. Yes, addition of all these diagonal elements. 8 and 2 is 10. Yes, this is your correct answer. Now second, this eigenvalues of symmetric matrix. Now remember this, if our matrix is symmetric, then surely eigenvalues are real. This is property. If matrix is symmetric, then eigenvalues are real. If matrix A is square matrix and then A into A transpose, A into A transpose, क्या होगा? ऑर्थोगोनल तो होने वाला है. If matrix is orthogonal, now A into A transpose. अब ऑर्थोगोनल होगा या नहीं होगा? We are not knowing. A into A transpose. Always this is not I. Identity हुआ तो orthogonal. Otherwise this is not. But what is, again, if you are not getting answer, then you should take a simple example. I will take this example, simple example, and then we will try to find out. Within 1 minute, we will get your answer. You can take a simple example, and then I will take here A, B, C, D into its transpose. A, B, C, D. Is it right? Now, what is its multiplication? A square plus B square. Here, A, C plus BD. Here, CA, or otherwise you can take numbers also. CA plus BD, and this is C square plus D. What is happening here? This element and this element is same. Then is it symmetric? Yes. Satisfying symmetry. Now this problem. Now this is interested one. This is from your comprehension level. Means what we studied till now. Consider matrix n by n. I have a matrix of order n by n. That means I will write n square matrix, and a non-zero matrix. यहाँ पे non-zero matrix P है of order n by 1. Yes, matrix multiplication exists. Then their product is, we are getting this A into P is equal to alpha square into P. A into P is equal to alpha square into P. Alpha is a real number. This is not in -1 to 1, 0 and 1 based on the given information. Then eigenvalues of A square. कौन बताएगा? Now I have this equation. I will use our definition of our eigenvalues. What is definition of eigenvalues? If Ax is equal to lambda x, this is our definition. Ax is equal to lambda x, then this lambda is called eigenvalue. This is eigenvalue. Okay, then this is eigenvalue. Which is our equation? This is my equation. AP is equal to alpha square into P. Just I will put here AP is equal to alpha square into P. Then what is eigenvalue? This is your eigenvalue. Okay, it is eigenvalue. Means eigenvalue for this matrix A is alpha square. अब अल्फा n डायमेंशनल है. एक तो आइगन वैल्यू पता है अल्फा स्क्वायर, एक के लिए एक आइगन वैल्यू पता है अल्फा स्क्वायर. देन व्हाट इज आइगन वैल्यू फॉर ए स्क्वायर? हमें पता है जो भी आइगन वैल्यू है उसका स्क्वायर करो, क्योंकि दिस इज प्रॉपर्टी. सही है ना? देन व्हाट इज योर आंसर?
Alpha raised to 4.
Oh, very good. Alpha raised to 4 means here only we have to use here our this property, and then we will get answer. If I have a matrix of order 5 by 7 and all entries are 1, we have covered this type of problem. All entries are 1. We have covered this problem. 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. Here, this is my this was our example, and all entries are same. Instead of 1, I will say same also. Then what will be rank of this matrix? इसका rank क्या था? 1 ही था. 1 ही था. Therefore, rank of this matrix is 1. If always all entries are same or equal to 1, doesn't matter 1 हो या same हो, doesn't matter, उसका rank 1 ही होगा. अब 5 by 7 है, तो कौन सा तो 5 by 7 होगा वो matrix. But try to remember that if all entries are same, then its rank is rank of this matrix. कैसे निकालना है रैंक ऑफ दिस मैट्रिक्स? डिटरमिनेंट से तो पॉसिबल नहीं है, क्योंकि इसका 4/4 का डिटरमिनेंट में टाइम बहुत जाएगा. तो क्या करना पड़ेगा हमें? कन्वर्ट करो एप्सिलॉन फॉर्म में. 5 0 माइनस 5 0, इसका 0 तो 0 है ही ऑलरेडी. ए से -5 को 0 बना. 2 0 1. हाँ, नाउ आई विल यूज हियर एडिशन प्लस -5 प्लस दिस becomes 0. Here, 0 1 0 2. अब क्या करना है? 5 0 माइनस 5 0 0 2 0 1 0. अब मैं यहाँ पे ये ठीक है, राइट है 0 0. हाँ, 0 multiply by this third row by 2, this becomes 0 0 third row by 2, and this becomes 0. Is it right? No, third row here is 4, here is 3. How many numbers non-zero rows?
3.
non-zero है, ये non-zero है, ये non-zero है. Actually, this is not echelon form. echelon form के लिए ये 0 rows है ना, वो सबसे नीचे होना चाहिए. तो ठीक है, anyway we have to find out answer, and we will. If now see here, if I will say that again, I will add here one more question. If this rank of this matrix is 3, then डिटर्मिनेंट ऑफ दिस मैट्रिक्स इज क्या होगा? ए स्क्वायर मैट्रिक्स है, I have this A matrix of any order, suppose 10 by 10 है, इसका रैंक सपोज 10 से छोटा है, कौन सा भी हो, सपोज रैंक ऑफ दिस मैट्रिक्स इज 3, then what will be determinant of this matrix? 3 हो या 9 हो, कोई भी हो. I will write here this determinant of this matrix, rank of this matrix is any 0, 1 to 9 में है, इसका determinant 0 ही होता है. Remember this. Determinant of this matrix is 0. Is it clear? हमने पहले ही देखा है, डिटर्मिनेंट जब 0 होता है तो ही हम सब मैट्रिक्स के बारे में सोचते हैं रैंक फाइंड करने के लिए. इज इट क्लियर? They can ask this type of problem also. If this matrix whose rank is less than order of this 5 by 5 है, सपोज उसका रैंक 2 है, या इस प्रॉब्लम में सपोज इसका 4 by 4 मैट्रिक्स है, इसका रैंक 3 है, तो डिटर्मिनेंट ऑफ A इज ऑलवेज 0, ये 0 ही होगा. और सपोज इसका ये 5 by 5 है, मेरे पास ए मैट्रिक्स 5 by 5 है और इसका रैंक भी 5 है, तो श्योरली डिटरमिनेंट इज नॉट इक्वल टू दिस. कितना वैल्यू है ये हम बता नहीं सकेंगे, बट नॉट इक्वल टू 0 है ये तो हम बताएंगे. हाँ ठीक है, इसका आइगन वैल्यू क्या होगा? एक बात तो क्लियर है, इसका आइगन वैल्यू के लिए एक आइगन वैल्यू 0 ही होता है. आई विल से दैट. सपोज आइगन वैल्यूज आर, एक तो 0 ही है, मैंने क्यों लिखा है 0? I had taken this आइगन, एक आइगन वैल्यू 0 है, ऐसा क्यों लिखा मैंने? क्योंकि इसका डिटर्मिनेंट क्या होगा? डिटर्मिनेंट ऑफ दिस मैट्रिक्स 0 है, क्योंकि दोनों रो सेम. If rows are same, then 0. If matrix is there and if this is a singular matrix, then surely at least one eigenvalue is 0. Matrix is a singular matrix. If A is a singular, that implies at least one eigenvalue. एक तो 0 होता ही है. अब मुझे पता चला ये सिंगुलर है, तो 0 0 में से चेक करेंगे आंसर, सभी में 0 डाला है. अब ये आंसर तो नहीं होगा. क्यों? क्योंकि हमें पता है, इफ सपोज व्हाट इज ट्रेस ऑफ दिस मैट्रिक्स, ट्रेस क्या होगा? लैम्डा 1 प्लस लैम्डा 2, इसका A प्लस 1 ही आने वाला है. तो क्या हमें पता है, दोनों जब हमारे पास आइगन वैल्यूज होंगे तो उसका ट्रेस A प्लस 1 आने वाला है, ये तो हमें पता है. अब A प्लस 1 ट्रेस कहाँ है? यहाँ है, और ये दूसरा 0. इन दोनों का एडिशन करने के बाद A प्लस 1 आता है, तो ये आंसर है. Is it clear? Hello. This is only by using the properties of eigenvalues. This is not our answer. This is not our answer, because I am checking trace of this matrix A. And trace of matrix is A plus 1. And हमें पता है एक आइगन वैल्यू तो 0 है ही, क्योंकि ये सिंगुलर मैट्रिक्स है. अब हमें ये चेक करना है कि लीनियरली डिपेंडेंट वेक्टर्स कौन से. अब मेरे पास जितने भी सारे सपोज x, y, z डिपेंडेंट, यानी कि दे फॉर्म्स रिलेशन. इसमें रिलेशन बनना चाहिए तीनों वेक्टर में. सपोज रिलेशन है, सपोज मेरे पास a है, कौन से भी 3 वेक्टर है, if I will form a relation in that, then we will get here dependence. अब देखो यहाँ पे ये थर्ड नंबर का जो है, this is cos 2 theta. What is formula for cos 2 theta? Cos 2 theta is equal to cos square theta minus sin square. ये फार्मूला गलत है. हाँ सॉरी, cos square theta है x, ठीक है. देखो cos square theta minus sin square theta, एंड इसमें ये फॉर्म है ना रिलेशन, ये रिलेशन में ऐसे भी लिख सकता हूँ, cos square theta minus sin square theta minus cos of 2 theta is equal to 0. They forming a relation. अदरवाइज किसी में भी रिलेशन नहीं है. If they are forms a relation, therefore these are the linearly dependent. Then now we will solve here. Here is also one technique. कौन सा भी मैट्रिक्स ले लो, ये जो पार्ट है इसको हम सिमेट्रिक पार्ट बोलते हैं. दिस इज सिमेट्रिक मैट्रिक्स. A into A transpose. A I have matrix transpose, and if I am taking A plus A transpose divided by 2, then this is called asymmetric. And A minus A transpose divided by 2, then this is called antisymmetric. Now for antisymmetric matrix, its diagonal elements are 0. Diagonal elements are 0. चेक करके देखो, कौन सा भी एक स्क्वायर मैट्रिक्स ले लो, इसका ट्रांसपोज करो, सबट्रैक्ट करो, ये बनेगा A एंटीसिमेट्रिक मैट्रिक्स, ये पार्ट, एंड ये पार्ट है सिमेट्रिक मैट्रिक्स. अब प्रॉब्लम कैसे पूछा है, and this problem I think this was recently asked in your exam. A matrix decompose into symmetric. कौन सा भी मैट्रिक्स ले लो, you can decompose this matrix symmetric and its q symmetric part. This is symmetric part, this is q symmetric part. यानी कि ये पार्ट दिया है उन्होंने. then what is the matrix of A? P. अब हमें पता है ये मैट्रिक्स जो है, ये मैट्रिक्स कैसे लिखते हैं, ये सिमेट्रिक प्लस ए एंटीसिमेट्रिक. अब ए सिमेट्रिक यानी क्या है, ए प्लस ए ट्रांसपोज डिवाइडेड बाय 2 प्लस ये क्या है, ए माइनस ए ट्रांसपोज डिवाइडेड. नाउ हियर दे आस्क व्हाट इज पी. सिमेट्रिक और एंटीसिमेट्रिक का एडिशन लेना पड़ेगा. सिमेट्रिक एंड एंटीसिमेट्रिक, इन दोनों का एडिशन करो. फाइंड आउट एडिशन ऑफ दिस. क्या है एडिशन, -4 तो एलिमेंट आने वाला है, ये 3 and 2, जहाँ पे आंसर ये तो फिर ये ऑप्शन गलत हो गया, और दिस 4 ऑप्शन इज आल्सो रॉन्ग बिकॉज आई एम टेकिंग एडिशन. दिस डायगोनल एलिमेंट, यहाँ पे डायगोनल एलिमेंट. अभी इन दोनों में चेक करना है कौन सा ऑप्शन. हाँ, व्हाट इज दिस 4 minus 2, we'll take addition. This 4 and this is -2 is 2. Therefore, this answer is correct. No need to find out here otherwise. Just do it here. आइए नहीं है. चलिए सर, मुझे फोन कर रहे हैं. Shall we continue? Hello. Shall I continue?
स्टॉप करते हैं.
Stop करना है. हाँ, ये कंप्लीट दो प्रॉब्लम तो सॉल्व करेंगे. ठीक है, अदरवाइज विल स्टॉप. शायद मैंने बहुत स्लो लिया. हेलो, मैं एक लिंक भी, एक मिनट, लिंक भी सेंड करता हूँ. हाँ, यू कैन फिल दिस फीडबैक लिंक. ठीक है, हम रुकेंगे. और अगेन हियर किसी को आपको डाउट है तो श्योरली यू कैन आस्क मी. इन एनी वे आई विल ट्राई टू सॉल्व योर ऑल डाउट्स. ठीक है.